Good afternoon to everyone that's joined. Thanks very much for your time, first and foremost. I think just a quick reminder from me before we start to keep cameras off and microphones muted, etc. That'll be good for us. Question-wise, do please feel free to stick them in the chat as you go, or we'll certainly make some time at the end to answer any questions anyone's got. The topic today that we're going to be discussing is the hybrid project. So introduced by Caden, and we've got the project partners up the top there. So it's not just Caden, the only distribution network that's participating in this. It's also, it's led by Northern Gas. We've also got Gas Networks Ireland, the National Gas Metering, part of the partners on the project. And today we'll be hearing from the technical leaders who are both. And we also work together with the IC. So it's a bit of certainly a collaborative project, which is one of the strengths, I think, already. And we'll take you through a little bit about various aspects. So it'll be a quick welcome. I think we've done that. I'll introduce you to the guys that are going to be presenting today, and then we'll give a quick kind of introduction from a distribution network operator perspective in terms of what the project is doing from our perspective and why we're investing in it, and then it'll really be over to the team at BOR to take you through the various different aspects, and we'll close up around 20 to 1 for some questions. So that's very much the plan. I think just briefly then with introductions. First of all, myself, my name's Brad Bannerman. I'm a future gas project engineer at Caden Gas. Been at Caden now for 3.5 years nearly, working in the end user hydrogen safety space for the last 3 really. So a lot of research that we've been submitting to the HSE and government to make the safety case for 100% hydrogen in the network. Before I hand over to the guys at BOR, I think that just the other point to make is this is our first PDN Lunch Learn event, and really the idea behind these, I think, humble beginnings this afternoon. But what we want to do is kind of create an opportunity for young professionals across the pipelines networks, not just gas. Hopefully we'll hear from various other industries in the coming months to shine the light really on projects that otherwise might not get the kind of attention I certainly feel they sometimes deserve. So it's an opportunity for that, for listeners to gain some awareness in things that are going on across the industry, and for speakers, it's really about developing those presentation skills and being able to tell the story behind, which is often quite technical work that are involved. So that's the aim. I'll hand over now to Dana to take you through the rest of the team that will be presenting you today.
Hi, I'm Dana. I'm a project engineer at BOR. So yeah, at BOR we do lots of different sorts of work for the gas industry. We do everything from sort of gas sampling and measurement all the way to servicing a biomethane plant. So yeah, I'm a project engineer, and I'm also a project manager of the hybrid project, which is going to be the subject of today's presentation. I've also got with me Abdul, who's the product design engineer on the project, and Shadi, who's an operations engineer at BOR. We've also got Matt, who's the director of innovation at BOR. Yeah, that's us.
Thank you, Dan. And just one last bit from me then, just introduction to the project, like I said, from a Caden or NGN, GNI perspective. Really what we've got here, this is very much an early image that we provided at the start of the project, so that's certainly not where we're looking to end up. But ultimately we've got, we're talking about gas safety, and automatic isolation of the supply is something that we commonly see today on natural gas operation in non-domestic sites, so industrial, commercial. We've often got solenoid valves which can be connected to various kind of methods of gas detection or other detectors, be it a control panel which gives you a means of isolating the supply in the case of emergency. I think from that perspective, they're quite chunky devices. They need base power and all that good stuff. And so from a domestic perspective, it's not the kind of thing that's non-disruptively installed in people's homes. So the hybrid project, I think, a little hint in that. I think against the background of hydrogen conversion, we've been working with HSE obviously, and they've always been very keen to see this idea of automatic isolation upon detection of a gas escape explored from a hydrant perspective. But what I would say is, I mean, this is a step up in safety, regardless of the kind of gas that we are conveying. So it's not just, well, it was perhaps a hydrogen background that brought us into this project. The product that's being developed is something that can be operable on any type of gas, so whether that's natural gas, biomethane, or blends of hydrogen. It's designed to be able to work on them all. I suppose where we are, as much as the innovation space that came working, we're also responsible for the National Gas Emergency Service. So the key point for us is, at the moment, natural gas operation. If we want to isolate supply in the case of emergency, we do so manually in the emergency control valve, and that means that we are very much relying on the householder, whoever it is, to be able to smell the gas, to be able to know they've got a leak, to be able to know to phone the number, to be able to know that they need to isolate the valve and isolate supply. So a lot of things need to line up there, and we've done some research as part of the wider hydrogen piece to understand customers' attitudes and behaviours, safety behaviours in the home. And as you can see with those numbers there, we've got less than 50% of over 4,000 people that we surveyed across the UK that knew how to operate an emergency control valve if they'd smelled gas and had a gas smell. So not a particularly great number. So that's one aspect. We also kind of introduced the idea of this smart technology in people's homes, so the ability for gas supply to turn itself off if it detected an anomaly of some sort. That was quite positively received in the survey work that we did. So I think all that combines itself into this project that we've got now, and that is what we're going to take you through over the next half hour or so. So yeah, enough from me. I'll hand over to Dan and the team to take you through the rest of the slide.
Yeah, Shani, things going to kick us off with what is hybrid?
Great. Yes, thank you, Brad. Yes, so as Brad mentioned, with the transition towards the renewable gases like hydrogen, we need to ensure that the infrastructure related to gas safety is ready. And well, there are gas safety devices in the market, but most of them are passive or just mechanical. I'll come to the animation in a couple of seconds. So that's why this hybrid project is there, because it was born due to the need to kind of rethink gas safety in a digital, a modern and a proactive way. So I would say hybrid is an evolution of an excess flow valve. So you can see in the animation, if you don't know what an excess flow valve is, it's basically a mechanical safety device that shuts off gas flow when it detects a sudden rupture or a large leak. A manufacturer of these excess flow valves is one of the manufacturers is called Teco. And here you can see an animation of how an excess flow valve works. So if it detects a very high gas flow that it's designed at, it automatically shuts off and it prevents damages happening to the system. But let's say the problem is fixed and the pressure is back to normal, and then the valve quickly reopens. So it works fine, but the whole idea is, this valve is purely mechanical and it's passive. So that's why we have hybrid. So hybrid is all about actively monitoring the gas flow, and it automatically shuts off when abnormal patterns are detected. And also it's a digital safety system which integrates all the cloud-based systems, and it can remotely connect with gas distribution networks and alerts and give alarms. So it's a whole package. It's a whole digital package which automatically aligns with the gas safety system. So that's what the hybrid project is about. If we talk about the benefits of this, so like we were saying just now, most of the current safety systems are reactive and they do their job, but it happens only after a significant event. So that actually leaves a safety gap. That's the gap the hybrid valve is trying to fix, because it brings in that proactive safety, and it's capable of detecting unexpected patterns before it actually escalates to a bigger level. And this project also supports the smooth transition into renewable energy. And like I said, so we use sensors, we use wireless technology, so we are kind of moving into that digital era. And it's that whole package which has wireless connectivity and everything. It also meets industry needs and industry standards. And we can say that hybrid, it delivers at an affordable and it's scalable in the future as well. So the project is NIA funded, and it's commissioned by Offshore. So through Energy Innovation Center, we have been working closely with NGN, PDN, GNI, and NGM. Just to quickly summarize the key functionalities of this valve that we are developing, it monitors the gas pressure and flow rate, and it responds to various safety scenarios. It can detect excess flow scenarios or insufficient flow, and it responds automatically to those scenarios. And it also provides that convenient way to turn off gas without needing to access an emergency control valve, which is specifically good for like vulnerable customers. And it has a detection system, and we can connect it to different systems like, let's say, a flammable gas detector. And like I said before, it sends alerts and give alarms. So the distribution networks are communicated on different aspects of it. So why hybrid is a strong solution? Yes, it is proactive. So unlike the gas safety systems in the market, it actually is a proactive solution, and I would say it's a whole package. And we think, so we are designing it with a 5-year battery life. So there is no ongoing maintenance, which of course reduces costs and minimizes disruptions in the gas networks. And in the future, of course, it can work with different varieties of gases. I mean, it can work with natural gas, hydrogen gas, or blend of both. So, it's easily retrofitable. So if you can see in the picture, it's designed to integrate with the existing infrastructure. So it connects to the end of the emergency control valve. So that means the networks don't need to take apart their whole system, but that upgrade can be done quite fast and easily. So that prototype you see in the picture, it's one of our early prototypes. And at the moment, we are at a significant level in this project. And I have to say, a lot of design thinking, testing, iteration, and lots of prototyping has gone into the project so far to ensure that we deliver this whole package of gas safety system. Yeah, and we will move on to the project approach and how we get to this point.
Thank you, Shadi. Yeah, so I'm going to go through team and project management. So yeah, you're already familiar with most of us here in the room. We've got Dan, who's not with us today. He's our digital and IoT lead. He's helping out with a lot of the wireless communication aspects of the project. So yeah, like I said, a lot of what I do on the project personally is project management. Work a lot with Matt, who's our technical lead on the project. And yeah, Abdul doing a lot of product design and development, and then Shadi's was helping out, doing a lot of the technology assessments. So yeah, where did we come from? Where did we go? To explain sort of where what the timeline of the project is. So yeah, the project commenced at the start of 2024, where we did the technology qualification process. So as part of that, we followed DNV's technology qualification process. where we risk assess the technologies on the project. So the first thing was the qualification basis, where we researched relevant standards and regulations that were important for the project, and that helped come up with our technical requirements for the project. So the top two standards are particularly relevant. So PAS 4441, which is components used in hydrogen gas metering, as well as the German DIN standard for excess flow valves. These were all really important for the project to define things like closure flow rates and how we carry out our monitoring processes. From a regulatory perspective, we had to make sure that we complied with gas safety regulations, both in the UK and in Ireland, as well as health and safety at work and GDPR data protection laws. So yeah, please don't try and read that. It's very small, but just to show you kind of the risk assessment that we did for the technologies on the project. So we did it for all the technologies that were considered novel. We didn't develop any new technologies, so sensors, batteries, they already exist, but it was all about the application. So things like sensors, batteries that have not really been used in this sort of application before. So we did a HAZOP and a HAZID, all to assess the risk of implementing the technologies, which then took us to planning and executing a variety of different experiments. And these were all to test sort of the mitigations from the risk assessment. So we put sensors through a grid and we tried to blow up batteries, all to contest the limits of the technologies. So you can see at the top, we put some sensors through a grid using a vacuum cleaner to simulate the abrasion caused by the sensor being exposed to 5 years in the gas stream. And then at the bottom there was a setup to test the explosive properties of different battery chemistries and compare them against each other. And these tests were really important to ensure that hybrid is de-risked, especially when we go into deployment, so that the GDMs can deploy them confidently. The next stage of the process is the product development process, which is where we're currently in at the moment. So the product development is separated into 6 distinct milestones, all based on different product functionality. We're currently in the 4th development milestone, where we've just delivered how to authorize the valve to be commissioned and decommissioned, and we're currently working on implementing wireless technologies. So one thing with the product development phase, yes, I'm going to move on to project variation, which is one of the challenges that we have to adapt to on our journey on this project. So we carried out a big scope change in October of last year. To give you a bit of background, the hybrid was originally designed with the Redcar and with the Hydrogen Village trials in mind. And if you don't already know, these were cancelled last year. So that kind of led over to the scope of the project to be revisited. So for this, we all presented and participated in workshops with the GDNs. We prepared a change request document with different potential scope changes, and that allowed kind of all the stakeholders in the project to make an informed decision. And one of the biggest changes that came out of that whole scope change was sort of a restructure to the project, which includes shifting the product development that I showed earlier from a waterfall project management approach to an agile project management approach. And I'm sure you've all heard of agile, and it's more than a buzzword. It's about executing projects in short cycles, which we call sprints. And that allows for rapid iteration, and it's really ended up being a really valuable way to make sure that we can adapt to changing requirements, and making sure that we're aligned with kind of any changes in the industry and requirements from the stakeholders. So to replan the project into agile, we broke down all the functionality to separate it into those milestones that I showed earlier. And as project manager, I've implemented a variety of agile tools. So like that on the screen is a Kanban board, We also do things like sprint retrospectives, where we look back on the lessons learned from sprints. We sprint plan at the beginning of each sprint to set clear objectives for what we're going to be doing. So we're currently operating on a 2-week sprint basis. And yeah, I'm going to hand over to Abdul to kind of explain the product development.
Yeah, thank you very much, Dana. So starting off, we had like a rough prototype in mind. We actually had like lots of ideas and different concepts in mind, and we sat through that and came up with the very first prototype, which is the solenoid system. And then we had the RFID. The RFID and a microcontroller to control the whole system, and a simple dashboard to see what's going on with the solenoid. And then below that picture is the pressure sensors. So we have the 2 different pressure sensors which we could use to monitor the pressure difference in the system. And then using that pressure difference, we could have like different logic that can control when the solenoid will go on and off, depending on like if there's high pressure, low pressure, and then that gives us like a reactive advantage over other things in the market. And then to the right, there's the flow rate test, which allows us to test the entire system end to end, so the pressure sensors, the solenoid, and the microcontrollers, ETC and flow meters in a simulated environment. And then in the next iteration, we had like a stacked flange system. So that's basically different slices of the different technologies we hope to integrate into Hybrid. So the pressure sensors, the solenoid, and the pressure sensors. This allowed us to see what works. What didn't work, we remove the slice out and replace it with a different slice to ensure that we have a more robust system. And yeah, so below that picture is everything's fully 3D printed. So 3D printing allowed us to prototype all of the parts, and we have all of those different slices stacked. To the right of that is the single body prototype, also in the test rig, and above that is a needle valve controller, and that allowed us to control the flow of the gas, and using the pressure regulator on it. Finally, we hope to combine and compress all of those into one final and pretty easy to integrate device that can go into the homes. So where did we come and where are we going to? So like Dana said, we are already in the Q25, and at the end of the project in November, we hope to have a product at the TR level 7 at the project closeout and ready to be installed at the GDN test facilities. Still to come. Yeah, so what's the future? What's next? We can't talk about all of this without talking about AI integration. So how are we going to integrate AI, you might ask? So previously we started off with an AFA which was reactive, does its work passively, and we moved on to being proactive, having pressure sensors and having the logic of when to go on and off. And in the future, we hope that it becomes predictive, where we can, if we gather enough data, we can forecast when maybe there's high demand, or maybe even the solenoid system is overheating, or we've gathered so much data we can forecast any failures and schedule maintenances. And for standards and best practices, we hope that hybrid becomes so revolutionary that it shakes up the standard system in UK or even worldwide, and allows us to even come up with even more practices to ensure that the system becomes more safe. And we would like for it to have like a digital aspect of it, perhaps like a digital twin of the whole system. And we hope that the UK transitions to a net zero future. Yes.
Right. So Abdul said we are where we are at right now. We want to say that hybrid is already gaining support from key players. Like you see in this picture, we recently installed one of our early prototypes at the NGN facility. It's a net zero research village. So if we continue to roll out hybrid, it has the potential to make 23 million homes safer. And of course, it aligns with the industry goals, like we said before, to move into the renewable gases and renewable energy in the future. And it supports the government policies. And well, according to our knowledge, a product like hybrid is not yet being deployed anywhere else in the world. So it's not just in the UK, but I think this project is setting a new benchmark for gas safety worldwide. So that's the impact we see from the project.
Okay, thanks. I'm just going to round up the presentation. So yeah, let's just summarize. The hybrid addresses key aspects like gas safety and gas network digitalization. We have to make sure that safety systems evolve, especially as we transition towards renewable gases and renewable blends. There are still hundreds of incidents caused by gas leaks every year. And solutions like hybrid are really key to making sure that safety and efficiency remain at the forefront of the industry's ambition towards achieving net zero. Through digitalization, we also enable this transition to be done in a smart and resilient way, to enable the gas networks to have a smart and resilient energy future. We're not just adapting to the future. I guess that's the other exciting thing, is that we're sort of shaping the future. And as we transition to renewable gases, like I said, we can do that confidently. The project is largely centered around product design and product development, with a lot of aspects like technology selection, risk assessment, prototyping, and testing both the bench and in test rigs. We do that using an agile delivery approach, which allows us to rapidly make changes. And we'll face some challenges, because one of the challenges with agile was that is quite a flexible approach and within quite a rigorous project. But we can do strict risk assessment in the technology qualification phase, and now we've got a very flexible agile methodology in the product development. So we're able to benefit from both approaches to different stages of the project. And in the project, we've been able to tackle key challenges like changes in scopes and adapting to the requirements of the stakeholders. And working with multiple stakeholders within the industry has meant we had to work closely with project partners and ensuring consistent and transparent communication. We do that through fortnightly meetings with the networks and provide them with monthly updates as well. But really, hybrid for us as kind of young engineers, it's been much more than an engineering challenge. Besides all the things that we've gone through now. I think, like I said, we've learned a lot through kind of working in an innovation project and kind of seeing how these evolve in the real world. So for me as project manager, I've learned how to lead in a diverse and dynamic environment. We all have very diverse skill sets, as you've seen, and that was particularly challenging to bridge knowledge gaps as project manager. We all also kind of work on a big variety of projects, and we all have to kind of tackle different priorities. It's been really good exposure to gas industry, working with the project partners and the GDNs, we've gained a lot of really valuable insights into how they operate, and what challenges the GDNs face when having to implement some new innovation projects. It's been really good for us. We've expanded our network, and we've been able to visit facilities and tour kind of their the research village. And yeah, I think it's been a really enjoyable part of the project. It's been kind of the collaboration and getting a practical understanding of how these projects work. And we've all learned to embrace adaptability, because that's part of the innovation projects, is that they very rarely follow a straight path, and there's always kind of unexpected hurdles, whether it's technical limitations or supply chain constraints, or as new requirements emerged. It was really important that we stayed on top of them, and things like problem solving through times of uncertainty has been really important skill for us to develop. And I know I speak for everyone saying that all the skills that we've developed will stay with us far beyond the project. Because it's not every day that you get to work on a project like this. It's been an incredible journey, and it's reinforced our belief that engineering is much more than technology. It's about enabling a better future, and yeah, that's what Hybrid is all about. Yeah, that's that's it from us. So yeah, opening the floor to Q&A.
Thank you. Yeah, thanks to the guys at BOR. Hope everyone's found that insightful. I think we've got 5 or 10 minutes or so. So if there are questions, please feel free to stick your hand up, pop cameras on, or stick it in the chat, whatever people are comfortable with. We'll do our best to answer. Well, we can start with Andre. So I'll take this one, and then Charlotte, I see you've got your hand up, so we'll come to you. I think, Andrew, your question: how long will pilot project last for once installed, and what are the biggest challenges that Hybrid faces that could stop its wider rollout? I think, well, I can give you the Cadent perspective, then I'll hand over to the board to see if we've got a different view on it. I think pilot projects in terms of these valves, so what we've, in the absence of kind of formal trials and kind of rollout of hydrogen or these valves on a natural gas network, what we're proposing at the moment is, once we get to TRL 7, we're then at a place where we can install these on purpose-built demonstration hubs. So NGN, the kind of project planners, they've got multiple homes up at the net zero village that Shadi was talking about earlier. So that's kind of where we're going first of all. I think timelines on that, nothing really defined. We'll install them, and we'll probably play about with them and see how they work in that environment, and then we'll kind of decide next steps from there. I think what's stopping wider rollout is it's certainly not a hydrogen. It's not requiring a hydrogen policy decision to be positive or anything like that. So I mean, these could be rolled out on the natural gas network today. I think I suppose it's appetite and kind of how you balance the cost of introducing the technology like this against the risk that we've got. It's a risk that we live with today. I suppose it's making the case to where we want to go and spend money rolling out these devices to bring that risk down further. So that's probably the biggest case we have to make. So if you guys got anything else to?
One of the challenges that we didn't cover so much in the presentation is a project in itself, is the cybersecurity side of things. And that's one of the things that we pivoted in the change request that Dana mentioned. And there's no way that you can introduce a valve to the UK market that could be shut off if a bad actor was to infiltrate the control system. So, being that the distribution network is a piece of critical national infrastructure, the level of cybersecurity protection has to be incredibly high, and making sure that you don't drown an innovation project in cybersecurity requirements is quite a tricky balance, and while also maintaining that kind of respect for where this thing could end up. So we wanted to focus on that particularly in this project. So the the Wi-Fi, is a very particular type of home automation radio, and is standardized and is battle tested and is used extensively in many industries. The communication back to an asset management platform would be, fully encrypted and to a secure UK-based data center. So the kind of the headlines, if you like, are important to get right, so that later on, if the project was to mature, you don't have to go back on yourself and rework things. The headlines are the correct ones, but to, like I said, it's a project in itself to deliver something that is so impervious to attack that you could use it on an airport or on critical national infrastructure like the distribution grid. But those would be the kind of the key things that I would say are the next steps beyond the project, beyond its mechanical trial, if you like, and its practicalities as a gas safety device. Is okay, what about the cyber issue, and making sure those requirements are deeply understood, and working with the distribution network operators to build a platform that they can interconnect with. There's no use making something that stands on its own and nobody can use. Even if it is really secure, it has to be able to connect to the gas distribution network systems. So that's a project in itself.
Yes, spot on that. Good pickup. Charlotte, you got a question?
Hello. That's actually really interesting what you just said about the cybersecurity, something that hadn't even occurred to me before, but that's really interesting. What I was going to ask is, I'm sorry, I'm going to apologize if you touched on this at the start. I was just 5 minutes late, but I went up to Spade Adam recently, and in their hydrogen homes, they were talking about having a flow meter that would sort of sense for leakage and automatically turn off the gas supply. Is that sort of an application of this? Is that what this is intended to be used for?
It's, yeah, very much in that vein. But yeah, as Brad was sort of setting out, the kind of the traditional way of solving these problems is with industrial and commercial equipment. And so, AIVs that exist today, like you could go out and make high break out of off-the-shelf components and stitch them all together into one big kind of briefcase of parts and essentially deliver the functionality, but it would quite literally be the size of a briefcase. So a lot of the work in this project is actually making it compact, small enough that it fits in a gas meter installation. Your average gas meter box, or under the stairs, or behind the dog's bed, or wherever else is you find a gas meter these days, and getting it into that environment so that it is a domestic setting that it's suitable for, rather than on a control panel with a PLC in a plant room. That's a very different environment. So it does work on that principle that it will monitor the flow. If the flow exceeds a set point, it will shut off. What I particularly like about the product is that set point is configurable. So the set point on Tuesday might be for a 20% hydrogen, 80% methane blend. The set point on Thursday might be 17% biomethane and the rest is natural gas, but all of those different gases have different flow requirements to deliver the same amount of power from the boiler or from the stove. And being able to have a valve that is suited for all of those different gas types is nigh on impossible. But being able to send a message to the valve to say, okay, it's a 20% hydrogen blend today, you know what to do, means the valve can then look for that new trip point for that particular calorific value of gas, which would otherwise involve going out and recalibrating all of the valves every week as the CV of the network changes in a sort of a future where we've got a lot more blended and much more variable quality gas.
Yeah. So how does it differentiate between sort of a small leak and someone using lots of gas on the hob and heating?
Sort of pick that one up because I feel like otherwise it's going to be the match for it.
So, sorry, you're talking about the tip-off point. Yeah, that
set point. Yeah.
Right. So we have identified a few scenarios based on the pressure and the flow rates We are looking at if the pressure for the flow rate falls beyond the design minimum pressure, or else maximum operating pressure. So likewise, we have identified those the flow rate points, and also we've defined a duration to see if the flow rate actually comes back to the normal position. Let's say like a 12-hour period. But if it still doesn't come back, then we kind of latch the valve shut. It's like a lockout situation where it would not automatically reopen. Then at that point, it actually goes to the point that a gas engineer has to visit the property and open the valve if everything is safe. So likewise, we kind of defined several situations where it goes into a closed position and also to a lockout scenario.
There's also the flammable gas detector.
Yes. So like we said, because we have connected it with some other systems like the flammable gas detector. So if the flammable gas detector detects something, then also it's linked to the hybrid valve and it will automatically shut. So that's why we say it's like a whole package. It's not just about the gas flow, it's also connected to other sensors, and it will react according to other sensors as well. So right now we are working on the wireless communication where the gas distribution networks will get information regarding the operation of the valve, and they will get some alerts, and it raises alarms if it comes to that point. So that's the part that we are working on right now.
Okay, yeah, that's interesting.
Thanks, Charlotte. I think we're done time-wise. I think, so we time to wrap up unless anyone's got any final burning questions for us. I'll take Sam's goal and everyone can go and have the rest of the lunch if they'd like. Okay. Thanks everyone for the time. I think this has been a good first session, and hopefully we'll be back with you with some other kind of insights in the future as the lunch and learn sessions progress. Okay. Thanks very much. Have a good day. Enjoy the rest.
Thank you.
Thanks, everyone.
Thanks.
Thank you.